All right, if you have your practice guides out. All right, now again, hey. Okay, now here's the idea. We're doing 3 questions today. We did 2 on Friday, 3 last Thursday, and today we're doing 3. The rest of the week we do 2 and then 1. It kind of ramps down. Semester practice guide, this thing that we're working on. It's due on Monday, January 4th. So make sure that if you've misplaced it, if you need another one, you have to check your email and make sure of.
I gotta grab my study guide so we're
gotta run. Okay, so it is due on Monday. So if you need to make a copy over the week or the week that you're off, or just take a picture of it and then you can study it for the next night. But it's due on Monday. Now, if you know you're going to be gone, you're going to have to just turn in when you're back. So, because I know some people have said they won't be back on vacation until afterwards. Question there, Hack?
I figured it out.
Okay. All right. So now, semester test is on Tuesday. It is a 1-day test. You'll take it in class. It's due before you walk out. That's why I'm probably the only teacher in this whole school that's over preparing you for this whole review thing. So that way you know exactly how to do each problem, what to expect, the types of problems I'm giving you, because they're not meant to be different, like changing like radically in terms of like manner what I'm showing you here. So I just want to make sure that you guys get to see the majority of what you're doing. But yeah, so the video today will be posted online after school. I have some time before my the girls basketball game tonight, so I'm just going to update the website right after school today. So it should be up really early compared to all the other days because I don't have to go to basketball practice or games or anything like that. And then over break, I just leave them up. So if you're on the website, here's the website, ghvmath.com or mrward.org. What was that?
Why is it outlined in green?
I'm sharing the whole screen so the people at home see that as well. So anything that's on that marker board is being shared. So instead of just the iPad screen. Yeah. So if you're on the website, you could scroll down and kind of see what we did yesterday in class. It's always like the previous day. And or you go up here to daily lessons. What was that?
I said I love that picture.
Oh, thanks.
Yeah.
But if you click the daily lessons, you go down to Calc. You can see all the videos for all year, except for I think the week of homecoming. I didn't post that one because there was no point. We just did shortened class periods anyway. But here's all your review. So here we go. The new one today will be over here, and you can click. If you click on it, it'll show you the details of what we talked about in class that day, kind of the idea of what questions we went through, what homework's due, all that good stuff. I gotta change that. I don't know why I have the 0 date for the 8. Oh, that's the Friday. You're right. That's the Friday. That's why this practice can just do that Friday. Anyway, I have pictures of each question if you can't see it. I have all of my work added to it, so the screenshots of the work we did in class. I just keep adding to that, so that just keeps growing. So there's going to be more and more slides here. I don't just put the ones we did that day. I have all of them, so I'll just add the next 2 slides we do. Okay. And then the video, obviously. Now, the reason why I have the screenshots is because when you watch the video, I have a little picture-in-picture down here in the corner because that's my audio. So if I don't have the picture-in-picture, you won't have any audio with the video. So that's added. So then that's why I include these pictures on the website so that way you can see the work in case it got covered up. Because like right here, you'd be missing all these bottom areas. So that's why I include the pictures. Some people can get away with just looking at the picture and go, okay, that's how he did it. It's nice to see the video to see my explanation of why things go the way that they do. So that's why I kind of have it all up there. But again, that's for the website. I know it's tedious. I just wanted to make sure I cover that so you guys are aware of where it's at, where it can be found, all that good stuff. Use it. That's why it's there. If you don't, no harm, no foul. All right. Questions before we begin?
Nope.
Okay, let's jump right in. We only have 3 questions today, and they're short and simple to the point. The next couple days could be a little bit different story. All right. Now, I'm just going to do a quick rundown. I'm not solving these problems out. I am just walking through what we discussed. So, question number 1. You're going to have to graph the parallel and graph the perpendicular. Make sure you know how to find the equations. You have to graph. For those at home, you're just going to draw it on a separate sheet of paper and then just kind of roughly draw in there and just kind of have the dots where they need to go. Just do the best you can. Okay? All right. 2 and 3, we did this one last Thursday. You had to use the logarithm. Hey, the big thing, you got to know how to use your calculator. If you don't know how to use this test day, there's no point. I will not tell you on test day how to type things in. You have to know it before you walk in. So those are good questions like the end of class. that Monday before we take it, how to use your calculator, those types of things, just to review simple things. If you lose your calculator, you can borrow mine, but I only have like 7 or 8 of them. So I don't have enough for all 15 of you. Okay? All right, next, number 4, we had to graph this. I think this is from Friday. We had to graph the sine function. It'll be a sine or cosine only. It'll be something where you have, what? 100%. Sine or cosine. I'm not going to pick weird, obscure ones. We can't do it. It will be some type of problem where I right and left shift it, up and down shift it. It'll have an amplitude. You have to know the whole process. Okay. 5, it'll be some type of problem like this. It'll have a horizontal, not a slant, but it'll have a horizontal type of asymptote. It'll have a vertical asymptote or 2. You'll have to find some x-intercepts, some y-intercepts, all that good stuff. So it should be factorable. That's what I'm basically telling you. And then you have to tell me the details. Just write all your details off to the side, kind of where those bullets are. And then obviously today we're starting on number 6 and moving to 8. We're doing 6, 7, 8 today. We're doing 3 problems. These are really quick, easy problems. Like even on the test they are. The reason why is I can't put like really difficult ones there because you still have to finish it in one class period, right? So it has to be something time manageable. So that's why I'm going to kind of walk through it. You just have to demonstrate you know what to do. On these problems, this one in particular, yeah, you have to kind of go through the details. 7 and 8, you do not have to simplify. That's the good news. And I'll warn you that on test day. Like, hey, these 2 problems, do not simplify. It'll just waste your time. Just move on. So I'll kind of give you those instructions, especially if, like, unfortunately, like, let's say over break, you have to be in quarantine when you have to take this thing online. I'll just, on the Zoom, I'll clarify that stuff. I'll have these pictures just like this so you can do them on your own paper. So hopefully that makes sense.
How was that test when you guys were in hybrid? So
I hated it.
Yeah.
That's my best test grade.
So, some people like it.
So everybody.
It's all over the
does
place.
all right. Hated it.
Okay. All right. Anyway, let's kind of walk through this one. I'm going to zoom in a little bit. I don't know if... Okay. Hopefully that shows up okay for you guys. I don't know how small that is. I'm going to have to go do like a bigger font when I do these for test day, if you guys are online. Okay, anyway.
It's the same as the last one, that's fine.
Yeah. The last one, I think I picked like 24, so it would show up.
I thought it was fine.
Yeah, so...
It was just hard because my screen, because you had to see my thing.
Oh, yeah, because I have to have your hands on the... Yeah, I understand that. Okay, anyway, yeah, so let's kind of walk through this. So first derivative, using the differential quotient. So this is going back to like those first, that first, I guess it was the second chapter test we took, the second unit. This is the formula you have to know. Now, you actually have to know this formula. It's not going to be printed for you. I think most people, once they hear differential quotient, we did this enough in pre-calc. You guys are probably pretty good at this. This is the differential quotient. You have to know that formula. It's a limit, right? It's the limit as x approaches, or sorry, as h approaches 0. Okay, so let's kind of walk through this one. All right, the setup is the hard part. It's getting it into the equation at first. You're taking this original function and I'm adapting it to plug them into these 2 locations, if that makes sense to you. I'm adapting them. So like on this first upper left corner, I'm going to try to color code this. This upper left corner up here, I have to plug in x plus h's into everything. So it's on the original equation I give you. So 5x plus h squared minus 3 times x plus h. Does everyone understand that that's my original function with x plus h is plugged in?
Yes.
If there is any weird number after it, let's say, no, I'm going to make this up. Let's say there was like a minus or a plus 8 back here. That just goes back here with no x plus h on it. If that was there. You don't have that, so I'm going to get rid of it. But if there's a plus 8, that doesn't have an x, so you're not plugging an x plus h on it. Okay? Now, we have to subtract the original function. That is this piece right here. We have to subtract the original item with nothing else other than x's in them. So 5x squared minus 3x. And yes, I am subtracting that item. And then this is all over h. Okay, questions on the setup. The setup is the hard part. The rest of the stuff is not difficult. It's not meant to be anyway. It's meant to be short, simple, to the point. Do you know what you're doing? Do you not know what you're doing? But this is the part, like just getting it set up in this form is usually where people go wrong because they just don't get the idea, the simplicity of what you're supposed to do. Okay. All right, so let's keep going. So the next part I'm going to do here, I'm going to figure out this item. Now I'm going to just do this off to the side. You can do it in the middle of your problem. I'm just going to do this off to the side so it doesn't take up a bunch of space. I don't have a lot of space here. So I'm going to be doing this x plus h squared off to the side. This is what I'm doing. Okay, so I'm just going to FOIL that out first, outer, inner, last, and then I'm just going to put it into that location. I'm still going to leave the 5 out front. I just need to figure out what that thing FOILs out to be. Can somebody walk me through this? What are we getting? First, outer, inner, last. What do we get?
5x squared plus 10.
All right, just without the 5. So don't distribute the 5 yet. So x squared.
Plus h squared. 2xh.
Yeah, there's 2hx's or 8xh's, right?
And h squared.
And then h squared. Okay, so that's if I FOILed first, outer, and last. So I'd have a x squared, that's first. Outer's xh, inner's xh, and then last is h squared. Now, I like the fact that you added the hx's together. That's great. You get 2 xh's. I don't care if they're xh's or hx's. It doesn't matter if they're the same. But that's FOILing first, outer, and last. That's the first upper left corner. Notice I didn't distribute the 5 yet. Okay, we'll do that here in a minute. Okay. Questions with how I got that weird parenthesis?
No.
Okay. Now, for the rest of this, I'm going to use a kind of a different color. What do we have to do with this 3 right here? Distribute. I'm going to distribute, and it is a negative 3 that I'm distributing. So this is a negative 3x and a minus 3h. Okay? And then with this negative sign right here, I'm going to distribute that in the back. So this is negative 5x squared plus 3x. And this is all over h.
It's just
Okay,
10x minus
are we good so far?
It's
Yeah.
just 10x plus 3.
Okay, all right, so now, so the next part here, I have to distribute the 5. So if I distribute this 5 over this parenthesis, you could simplify that before you do this. I'm just going to distribute it. It doesn't really matter. So this is 5x squared, a 5xh, or hx, however you want to write it, plus 5xh, plus 5h squared, and then the minus 3x, minus 3h, minus 5x squared, and plus 3x.
Oh, I didn't distribute the negative sign.
Yeah. And all over h. Okay. Hopefully that makes sense what I just did there.
Yeah.
Okay. Now, what is the rule if you know you're doing this part right? What should happen?
Things
Everything that
cancel
doesn't
out.
have
Like
an
terms
X
cancel.
cancels
Yeah.
out.
Opposites cancel.
Anything that doesn't have an h should cancel out. So that's kind of nice that you always have kind of like a backup in case you can't tell what should happen. Things that don't have h's should cancel out. So like the 5x squared,
Well, and
negative
the
5x
power
squared.
rule, which is
Yeah.
glorious.
Yep. And then 3x and 3x. Yep. You can cancel those out. And everything else has h's on them. And yeah, just if you didn't hear Isaac, you're absolutely right. If you need to check your answer, the good news is you guys know power rule. So you can go back to the original problem and just check with the power rule what the answer should be in the end anyway,
So
which is
glad I
nice.
didn't know that in pre-calc.
Yeah, so yeah. Some people kind of figured it out, but yeah, that's a good rule to know. All right, so
Pre-calc, somebody figured out the power rule.
And didn't tell everyone?
yep.
Was it you, Wyatt?
No, it was Luke Hansen.
And he didn't tell
What?
everyone.
What?
It was
He
Luke
didn't
Hansen.
tell us?
It was Luke
Okay.
Killing him.
I tried to
All right.
it worked every time.
Okay. All right. Hey, the last step here. The last step. Or actually, there's 2 steps left. And I took a screenshot so I could get rid of some of these pieces here. All right. Oh, I shouldn't have erased that.
Yeah, you should just read.
All right. So I already did.
Good.
All right, so I'm going to leave that up there because there's something I need to explain. All right, the next thing I'm going to do here is I'm going to divide everything.
By 8.
I'm going to divide everything by h. This is called the law of division. I'm allowed to divide 1 h off of every item, just 1. And then we'll simplify it after that. So this turns out to be 5x plus 5x plus 5h minus 3. That's after I divide everything by h's. And what should happen last is what you're seeing with that limit. The limit up above, if I go back to what the original problem should have been, they told you at the very last step, I have to plug in zeros for all my h's. So I have to do that now. After I divided them off, the limit's going to approach where h is 0, and that should be your last step. So your final step, if I plug in zeros for my h's, I should be left with this, which if you want to leave it like that, that's fine. That's your final answer. Some people like to go further and write down what that is. That's 10x minus 3. They're the same thing. I accept both. I don't really care. As long as you showed me the work and how we got to that step.
It's not gonna be like a 1 or something at the limit, will it? Like
For
eight?
like for the final thing right there? No. No, it will. For when we do differentials, so h always has to go to 0. Yep. If you want to go to a different number, that's when you have to evaluate. That would be more of like a Calc 2 kind of a thing. So. Okay.
What?
All right. Questions.
Nope.
Next.
So you don't have to do all that work, you can just do the power rule?
No, you have to, because this problem specifically says you have to use the differential quotient to show me the work. If you don't use the differential quotient, I count it wrong. Right? It's just nice. It's nice that you know what the final answer is, that you can like double check to see if you did it right. But this is the original like limit formula, because there's some problems where when you get down to like complicated mathematics, like there is no way to attempt the problem with power rule because there is no power to deal with. So we have like weird trig functions and other things, and sometimes the differential quotient is the only route we could go. So there is a reason why they have it. This is like the original method, and then they figured out there are shortcuts that apply to certain problems like polynomials, like in your case. Question?
Tiara Keeney to the office, please. Tiara Keeney to the office.
Isn't there like a whole college class that's just differential equations?
Yeah. Yeah.
Is it easy?
No.
No.
DiffyQ, yeah, DiffyQ is it's one of those courses that it's like what we're doing here, but they do it for really insane problems where the problems I remember doing in differential equations was, you have a big tank of water, 88 gallons of water tank. There's a certain spigot that's pouring water in at a certain rate, and there's another spigot pouring water in, and then there's a spigot at the bottom pouring water out of the tank. And the tank has a certain like chemical mixture, and this spout is spitting a certain chemical, and this spout is spitting a different chemical in. When will they be at certain percentages at the very, at a certain point? Like what point, like 15 minutes down the road, would it be like 15%, 22%, and 75%? And you have to figure out like when they'll hit certain numbers. And every day it was a different problem. And it was like something weird and unique. And it was like, for engineers it made a lot of sense because they're constantly like dealing with that type of stuff. But for like a math major that has never had to take an engineering course, because I didn't have to unless I wanted to go into engineering, like the problems didn't make sense to me at first. I was like, I have no idea what you guys are actually working on. Like I understand the math. I could they could do this stuff, and I'm like, well, I know how to do that. But then like where they're coming up with their numbers, because they had like crazy shortcuts that they were doing. Because of like their engineering courses taught them like this is what you do when you see a certain number here, here, and here. You use those numbers and it creates like a ratio, and you use that number to like balance your equations out. And I didn't know that. I was just doing this stuff the whole time, and I was really good at it. I was fast. But then they look at my math and they're like, we have no idea what you just did there. I'm doing calculus. And they're like, yeah, we got shortcuts for that. You don't even know how to do real math anymore. All right.
Okay, let's pound these 2 out.
Okay, last two. These are pretty straightforward. This is a product rule problem. The next one says quotient rule. If you look at your practice guide, they're under the same heading. It's a product rule and quotient rule. These were in the same units that were in the book. You definitely need to know how to do these. There's no way you can't just like mess your way through it. You have to demonstrate you can do a product or a quotient rule without cheating it. Without, like on this one, foiling that stuff together and just making a huge polynomial and then just doing the power rule. I don't want that.
That's a way.
That is a shortcut, right? Or it's not a shortcut, it's just a different method. I want to see that you know how to do the real product rule. So, product rule, if you don't remember, it is where, this is the formula. It's where you have two different functions being multiplied together. So it's like, I always call it first and second. right? So the actual formula for finding the derivative is you take the derivative of the first times the second function, the normal second function, plus the derivative of the second function times the original first. Like that's the normal formula. Now I'm using H's and G's. The book uses first and seconds, so it makes sense. But we're gonna just do this. You do not simplify. In fact, I'm gonna write that up here. Do not simplify.
Don't sin.
Don't sit.
Don't sin. I could have known that.
Okay, do not simplify. Okay,
Put on this ass. Don't be a simp, be a pimp. And then we'll
I don't want to get fired. No. All right, so moving on. All right, so first derivative here. All right, so first derivative, first parenthesis. That's my G. I have to find the derivative of that item. So let's just do normal power rule for this. What do we get?
-4 minus 6x.
-4 minus 6x. Good. That's the derivative of the first item. Hey, guys, can we stop talking? It's kind of upsetting me. So first derivative, and then we take it times the second. Then we're going to add the derivative of the second parenthesis, which ends up being what?
30x to the 4th minus 3.
30x to the 4th minus 3. Good.
Times 2 minus 4.
And then we take it times the first. Yeah. 2 minus 4x minus the 3x squared. And that's your answer. You can rearrange, you're fine. Yeah. As long as you have that item, right, where you have the two parentheses, the plus sign between, and you leave it like that, I don't care the order you write them in, you're fine. As long as you're demonstrating that you know how you're writing it. That you have the derivative of the first times the second, the derivative of the second
It
times
really
the first.
bothers me that you put the square root of the last number and like it's ascending order instead of descending.
Yeah, I know, yeah. And that's she was saying, like, can I rearrange? Yeah, I can rearrange. So it's in descending order. That's it. That's all I want. I don't want you to simplify that. That is the original problem. That's what I just want, just like that.
Not even second derivative?
Nope. This was from the first sections where you're just doing first derivatives. So, nope.
Oh, it's not the second.
Okay, it's gotta be quick.
So I'm not-
Okay, are we good?
Yes.
Moving on. Last problem of the day. Quotient rule. It's still in the same directions. Sorry, I just didn't have a header up there. Do not simplify again. The quotient rule, if you don't remember, for finding the, so that I'm gonna just kind of write it original. So this is using H's and X's again. So here's what we have. So when you do the derivative of this thing by formula, the first derivative, this is the order we do. We do derivative of the top times the bottom, the original bottom, minus the derivative of the bottom times the top, all over the bottom squared. And again, I do not want you to simplify this problem down. Now, I don't like the way I wrote that.
Would it be H squared?
Oh yeah, H. Sorry. H x squared. Okay. All right. All right. I like that. That looks better. All right. So let's go. Let's walk through this. This again, it requires that you really pay attention to the form that we're writing it. So first derivative. Okay. What is the derivative of the top? 6x. Good. Now we take it times the bottom, which is
5x squared plus 7x.
yeah, 5x squared plus 7x, because that's the original bottom. Now we have the minus sign. Derivative of the bottom,
10x plus 7.
10x plus 7. And notice I'm putting it in parentheses. Times the top.
3x squared. Are you going to make us type this in a Google Form too?
No. No, you have to put it on a piece of paper and take a picture. No, it's got to be quick. That takes too long.
Oh.
If you're online.
Ward, how do I know not to try to put that up on the top for the negative first?
Huh?
Because some of the stuff we had to put like 5x squared plus 7. We had to throw it up on the top, you know?
That's what we did.
Oh no, that's if you change
That's
the power
different.
tool.
Oh, you're saying like you change it like the power to be a -1 and you move it up? We're not doing that.
Oh! Yeah.
Yeah, no.
You make weird
It's
it's fun.
Okay, all right. And the last part, the bottom squared.
Brody's being wild today. Birthday Brody's going.
Okay, there you go. That's it. Done. Move on. Don't simplify. It's meant to be a quick hitter. Can you demonstrate you know the formula? That's basically it. Moving on.
Ford, what is my best chance of getting to be on a co-ed floor at Iowa State?
A co-ed dorm?
Floor, yeah.
Depends on the dorm you want to live. I can point you in the direction where you want to
I
live.
went Willow Larch because I
Okay.
heard those have co-ed
But they're
floors.
crappy dorms.
Yeah, they're crappy. Really? All the original dorms are really kind of dumb.
But Maple was redone.
Oh, really?
Maple got redone.
Ooh, I didn't know that. It's been a while since I've been there.
I just switched my preference today because I heard that there was co-ed dorms in Willow.
All right, hold on. All right, bye guys. It's good to see you again. Hopefully you guys are good, taking care of yourself. How you guys feeling? Feeling good?
Like a triangle.
Okay, that wasn't convincing, Morgan. That wasn't convincing. All right, I hope that you guys take care of yourselves. So, hopefully I'll see you back. Again, you can watch the videos if you have questions. Don't be afraid to email me. You know, I'll make some videos and whatnot. So hopefully this is working for you guys so far. Just put this stuff on a separate sheet of paper, and then that's what you'll turn in when you're back. So, okay. All right. Thanks, guys. Bye.